We're working on solving applications of quadratic equations. So our goal today is to model and solve a variety of problems involving quadratic functions and equations. So for example 1, we have 40 meters of fencing available to enclose a rectangular pen. So we've got a rectangle, which we'll just draw a picture. Sometimes with questions like these, it helps to organize our information with a little sketch. So I've got a nice little rectangle here, and we know that we've got 40 meters of fencing to go all the way around that pen. So let's call that L for length and W for width. So that means that I would have 2 lengths and 2 widths to enclose the pen, and that has to equal 40. All right. Okay, so 2 lengths plus 2 widths has to equal 40. Along with that, we want to represent the area of the pen. So area, we know, is length times width. So really, again, we've got equation 1, equation number 2. I'm going to take this equation 1, the perimeter equation here, and solve that for either my length or my width here. So let's solve that for the width. I'm going to have 2 widths equals 40. Take away the 2 lengths. So I'm taking away 2L from both sides. And then I'm going to divide everything by 2 here. And when I divide everything by 2, we're going to end up with 20, because 40 divided by 2 is 20, and minus L. So now what we have is area being equal to length times width, but width is equal to 20 minus L. All right, so now we have an expression here. We could expand that if we need to. This also could be written as 20L minus L squared. Okay, sketch the function, include the intercepts. So if I look at that, my L is like my X, and my A is my area, my Y is like the A. From the factored form, I'm going to go back up to my equation here. I've got x-intercepts here. I've got it in factored form. L equals 0 is one of the x-intercepts, and the other one would be 20 minus L equals 0, which gives me 20 equals L. So we've got an x-intercept here, x-intercept here. We'll label this as a 0 and this as a 20, and this parabola is opening down based on the leading coefficient, so I'm going to sketch that. So there we are. We could get our maximum based on what we have here. The maximum is going to happen at 10 because it happens halfway between the zeros because of the symmetry. So your area when length is 10 would be 10 times 20 minus 10. I'm just taking the formula here and subbing 10 in, and then that will equal 10 times 10, which is 100. So our maximum area for that pen would be 100. So our vertex is here at 10, 100. All right, what dimensions would provide for an area greater than 90 square meters? So if this is our 100 right here, we're really looking at the 90, and we're looking at what values, what range here to here is going to produce that area. So in order to work with that equation, we could take our area equation. I'm going to take the expanded form that we have here, and we want to say we're going to set that equal to 90 so we can solve for the values that I pointed to. In the graph up above. Okay, so I'm going to get everything to one side. We're going to have L squared minus 20L. I'm just moving the things on the right, plus 90. I'm just moving everything to the left side of the equal sign and having 0 on the right side. And now I could try factoring that, or we could go directly into the quadratic formula. Because I'm tired and I don't want to think too hard about that, I'm going to go directly into quadratic formula. So instead of x equals, I've got L as my variable, so L will equal negative b, so negative 20, plus or minus the square root of negative 20 squared minus 4 times 1 times c, which is 90, all divided by 2 times 1. Okay, so give yourself some time, figure that out. I'm going to jump directly to my answers because I don't have tons of room here to work with that. Okay, so my L worked out to be, I'm just going to simplify this briefly, plus or minus. I got 40 under the square root sign, all over 2. L was approximately equal to 13.16, or L was approximately equal to 6.84. Okay, so those are my values that I was pointing to here in my diagram. So your lengths need to be between those two values to produce an area greater than 90 square meters. Now we could sub that L in and solve for the W as well, but given time and the room that I've left there, I'm not going to do that for that question. All right, moving on here. Okay, company makes canoes and sells them for $500 each. At this price, it sells 60 canoes in a season. The revenue, to increase revenue, management is planning to increase the selling price. It estimates that for every $50 increase in price, the number of canoes sold will drop by 4. So revenue is the amount of money that a company will make by selling a product or selling a service. So in this case, it's the canoes they're selling. Your revenue is going to be the number sold times the price they're selling them for. So that is something you should know. You've probably done some revenue questions earlier on in your math career, but in this case, we are just reviewing that again. So our revenue will be our number sold, and I actually write this down so I can keep track of what is what, because when we get into more complex questions where we're dealing with costs and we have to get profit, then we need to know what pieces of the equation represents what. So we've got the price sold for. So the number sold, we're starting out with 60 canoes being sold in the season. So I'm going to start that bracket with 60, but I'm not finished with it, so I'm not going to fill that in. And we're starting with a selling price of 500. Okay, so my revenue would just be 60 times 500 if we don't change anything. But they're planning to increase the selling price. So this price of 500 is going to have something added to it. It's going to add groups of $50. So we're going to add 50, but we don't know how many groups of 50. So we're going to put 50 times X, where X represents the number of $50 increases in price. But as we add $50, for every $50 increase in price, the number of canoes sold, so the number sold will drop by 4. So for every X, every $50 increase in price, the number sold will decrease by groups of 4. So my let statement here would be, or I could say where or let X represents the number of $50 increases in price. Okay, so these take a little bit of time and practice, but keep persevering with these questions and make sure you understand how to do them. All right, sketch the function. Determine the values of the horizontal intercepts and the vertical intercepts. Well, for our x-intercepts, our revenue function already is in factored form, so you could just set each factor equal to 0 and solve the little mini equations for that. So we're going to get 60 minus 4x equaling 0. I'm going to add 4x to both sides to make it positive, divide by 4. We're going to get x equals 15 out of that. The other one, we've got 500 plus 50x equals 0. that's going to give me 50x equals negative 500. Divide by 50, x will equal negative 10. Okay, so if I go to sketch this function, I'm going to have a value at negative 10 and positive 15. And my parabola, if I expand and simplify that, I'm going to have a negative x squared. So my parabola is opening down and could look something like that. Okay, so my vertex is going to be halfway between there. For my y-intercept, or in this case my r for revenue, my r-intercept, I could let x equal 0. And if we let x equal 0, that really is giving us what our initial, so these would end up being equal to 0. It would give us our initial revenue, which is the product of these two values, which 60 times 500 is $30,000. Oops, I have the wrong tool out here. There we go. So 30,000 is our y-intercept here. Okay, just let x equal 0 for that. All right, from there we could actually get the vertex. I could find the midpoint of these. So add 15 and negative 10. We get 5, and then divide by 2. That's going to give us 2.5. So the x-coordinate of our vertex is going to happen at 2.5 to get that maximum. And that will help us for our next question, which I'll do on the next video.